Everybody, welcome back. It is now 12:30. I think I've got 35 or 36 here. So let's go ahead and get started. Our next presentation is from a familiar face, John McDonald from GE Grid Solutions. John, do we have a formal bio for John? Does John need a formal bio intro, or do we all know John and we're just very happy to have John here with us to talk to us? John is the SmartGrid Business Development Leader for North America, Global SmartGrid Strategy Group, GE Grid Solutions. John, is that acceptable to get you started here?
That's perfect.
All right, sir. Thank you very much for being here. We're happy to have you.
Thank you very much for the opportunity to come back. Enjoyed being here in April. And so what we'll do, we'll focus now, I know in April was a little bit more general, focus more on integration and interoperability. And we've had some great talks this morning from Jeff and from Mark. And now we'll piggyback on those and we'll go into more detail on three key areas this afternoon. But this is a little bit about my background. You know, I've been working in the SmartGrid area for 43 years full-time. About 2/3 of that with 4 different automation system suppliers, and about 1/3 with international consulting with electric utilities. I think what's important though is, and we've talked a little bit about this with both Jeff and Mark this morning, is in the industry, we do this at GE, the utilities do it, we're making business decisions, very important ones every day for our groups, for our companies, and we need to have a better idea of what's happening in the world around us. You know, what are the key industry trends, the key societal trends? So I'm just summarizing a few here. You know, in the 10 years we've coined SmartGrid and used that term. It's an opportunity for us to transition from devices and systems which we see as traditional products. You know, we get some voice of customer, we go back to GE and we develop a product, then we go out and we try to sell it and we hope we develop the right thing. Now with SmartGrid is holistic solutions. 2 important words. Solution is a set of technology components integrated together to meet the business needs of the customer, the electric utility. Holistic means we don't want to do this just for one group in utility, but we want to do it holistically, company-wide. Okay, we've got to break down the silos of the way we operate and look at the whole company. And I'm going to show some examples of holistic solutions. Success is not just technology, but it's standards and policy. And we're going to really emphasize that this afternoon. We tend to focus on technology because that's the sexiness, the stuff that really interests us. But as we'll see, well, as we heard this morning and as we'll see this afternoon, I can have the best technology in the world, but if it's not standards-based, it won't integrate and interoperate, okay? And it won't be successful, okay? And one of the lessons we learned after 18 months of deploying SmartGrid projects was how important standards were, okay? And lastly, we could have technology that's standards-based, but policy incentivizes the customer to buy the technology. So policy is very, very critical. We're going through a change in culture. So it's one thing to have technology, but to get that technology accepted, right? We can all talk about it, but to get it accepted, there's cultural challenges and changes within electric utilities. One would be having confidence in the logic on the distribution system where I can close the loop on the logic. Okay, take the human out of the loop. When a fault occurs and I detect it, I locate it, I isolate it, now I can do upstream and downstream restoration, right, automatically. I've tested the logic and I have confidence in it. And that is very important with improving the reliability of my distribution system and what we call resiliency and self-healing capabilities of the grid. One of the interesting things now is there's much more emphasis on microgrids because of more emphasis on resiliency of the grid. If I have one interconnected grid, if there's a problem, if I don't isolate it quick enough, maybe my whole grid will come down, or a big portion of it. If I subdivide my grid into smaller microgrids that are self-sufficient with their own generation, some part of that's renewables, and I can disconnect a microgrid from the bigger grid, I get some resiliency, okay? And we did a survey 3 or 4 years ago at GE with Gallup, and we surveyed thousands of utility customers, and we said, how many of you would be willing to pay $10 or more extra per month on your electric bill if that extra money went to making the grid more resilient? And 41% of those east of the Mississippi said yes, and 34% west. The reason is the ones east of the Mississippi have experienced 3 times the outages, those of the west. But it shows that the general public is very concerned and willing to put money towards improving the resiliency of the grid. Big data, we're going to talk more about that this afternoon, and I've got some slides on that. The cloud, I mean the consensus and the EMS user group, which is the key vendors and the utilities that have SCADA systems for generation transmission. Consensus at the user group meeting that I spoke at last year was that the future platform for the EMS system, the generation transmission control system, is totally cloud-based. Okay, so we've heard about the cloud. Mark talked about what we're doing at GE with the digital twin. Predix, which is has a lot of cloud components in the platform. We're going to do more of that. Social media. I think we need to empower customers to use social media to a greater extent. In the same poll, we found that 70% of the customers would prefer to interact with their electric utility through social media, not landline phones, okay? Very few millennials, if any, have landline phones. So we need to think of a new way of interaction, and it's social media. We're going to talk about convergence of IT and OT and how important that is. It's foundational to SmartGrid. And I think what's important is let's emphasize integration to the point of, okay, give me a reason why you say integration is so important. Well, a typical project today, when a utility purchases an ADMS, an Advanced Distribution Management System, the consensus and the results are that 30% of the project cost is the SCADA system from the vendor, but 70% of the project cost is the cost to integrate that system with all the other systems and devices within the utility. And a measure of the resiliency of that utility's grid is not the quality of the ADMS as much as how well they did the integration. Integration is key, is very key to maximizing the functionality you're getting from the technology you're buying and truly having a resilient grid. And then we emphasize this all the time is before we start thinking of adding new things to the grid, let's make sure we have that strong foundation. You know, a strong grid before a smart grid. And that's what this afternoon's about. When we talk about strong grid, we're talking about communications infrastructure and the IT infrastructure. Okay, let's make sure those are sound. You know, if you have a concrete foundation, there's cracks in it, but you're really more excited about building your house, and you start framing a house on top of that cracked concrete foundation because you're more excited about the house than really going backwards and checking out your foundation, eventually you're going to have a problem. Okay, same. We need to make sure we have a strong grid before we start overlaying new technology on top. Okay, so when we talk about an integrated solution, we said, what are the business needs, the pain points, the operational needs of utilities in general in the United States? And we took that information and we said, how can we put technology together in a way that has the strongest business cases in general for electric utilities in the U.S.? And these were the 6 integrated solutions that came out of that. Asset optimization, which today is transformers, monitoring and diagnostics of key transformers. Demand optimization, we've heard about the term DERMS, Distributed Energy Resource Management System, and demand response. Smart metering and two-way communications. Distribution optimization today, I think people would agree, it has the strongest business case of anything that we do here. Some organizations have said for every dollar we spend and invest in distribution, we get $5 to $6 back. In other words, a benefit cost ratio of 5 to 6 to 1. It's very strong with short payback periods. Transmission optimization, working on that today with a lot of new things, but distribution, I would say, has much more focus today than ever in the history. And then lastly is workforce and engineering design optimization. You know, PricewaterhouseCoopers had a report recently that said in the energy industry in the U.S., 40% of the workers today and 60% of the executives will all retire within 5 years. So it's very real. We really need to, how do we capture the experience that we have, and then how can we entice, you know, attract young professionals into our industry, okay? So this is, if we take those 6 solutions and you do a technology roadmap, I know it's a busy, but it shows those technology components all around the grid where they're located. Upper left is office or control center, lower left is substations, lower right is out on the distribution feeders. But just to highlight the importance of integration, interoperability, and standards, just take a look at the light blue boxes here. Those boxes are all involved with distribution optimization. Software applications, systems, equipment in substations, also equipment on feeders downstream of the substations. Think about, you're doing a project at a utility. These blue boxes are all from different vendors, all speaking, having to speak with each other and exchange information with each other. And this is not trivial. This is a challenge, okay? This is why standards are so key. Integration, interoperability, this is very real. These are the things we're doing today with utilities, okay? Distribution optimization. So one of the things, the integration is very key, and I'll give you some examples. So there's 5 key components we say that a utility needs to invest in as a first step. Smart meters, AMI communications, geographic information system, outage management system, and distribution management system. But again, the bottom line is the integration of these together. So from the smart meters, we not only get the meter readings, but on long feeders, when we do voltage and reactive power control, we can ping certain smart meters at the ends of long feeders to get the voltage. Because the standard in the United States is the voltage at your home must be 114 to 126 volts, 120 plus or minus 5%. It's an ANSI standard. So when I'm doing voltage control, I need to make sure I know on a long feeder with a lot of voltage drop, what is the voltage at the end? You know, I need to know that. And I can get that from smart meters. Also, when an outage occurs, a smart meter has a pass-through that is charged when the meter is energized. When we have an outage, there's enough energy for one final communication from the meter up to the utility. We call last gasp communication that says, hey, there's an outage and this is the time it occurred. That's valuable information for the utility because you know which customers are out and the time it occurred. This is part of the information with the integration that I talked about. Geographic information system is the reference system for the network model for outage management and distribution management. We take status changes from the distribution management system and we send those to outage management. Well, that one status change tells outage management that a feeder now doesn't have electricity. Outage management knows all the customers connect that feeder. So it knows which customers are out and the time it occurred, just from one piece of information from the DMS. And then we're empowering customers now to a greater extent. And one thing we're doing is using Twitter and tweets. So take the handle, the Twitter handle of customers, put that in their customer information record. So when a customer sends a tweet with outage information to the utility, we know which customer it is, the property address through the Twitter handle, okay? And again, 70% of the thousands of customers we surveyed said they prefer to interact with their utility with social media. So IT-OT convergence is very important, but we need to look at data. The data we have around the grid is not all the same type, and we need to manage it differently. I wrote an article in 2003 that introduced us to the industry that we have operational and non-operational data. The operational data is what we're used to. That's the information that the operators in the control center need to monitor and control the system from the control center. Okay? That's what we're used to. It's typically points like analog points, current, volts, and status points, circuit breaker open or closed. Non-operational data is the information that's in these devices, but the operators in the control center aren't interested in it, but one or more other groups in the utility are interested. Maintenance group, power quality group, the asset management group, planning, okay? And this is very valuable information. This is not only points, but it's digitized waveforms. It's a sequence of events file. So this is both files and points. And as time goes on, the way vendors differentiate their devices from competitors is putting more and more non-operational data in these devices. We need to make sure we take advantage and use that. And this is just characteristics of the two. Operational data is more real time. We use industry standard communication protocols to extract it. Non-op data, points and files, it's more historical. In some cases, there's vendor proprietary protocols to extract it. Okay? Now, this is our goal. On the left here, each of the groups in the utility has their own systems, their own devices, and their own databases. And they're very happy with getting their own data and using it for their own needs. On the right, Jeff talked about a platform, and some of you asked questions about the platform of the future. On the right, we're showing the ideal situation where we've brought together holistically the devices, the systems, and the databases of every group in the utility with a federated data mart, and it's more of a logical linking. You're not throwing things away, but you're logically linking it together. And the bottom line is when there's a piece of data in a device that the protection group bought that maintenance would like to have, that we identify that, it's extracted, brought across the firewalls for security over to the corporate side, and maintenance has access to it. Okay, so it's truly mapping data from all the data sources. We can't have a disconnect in the enterprise, so we got to bring IT and OT together to make this happen, and the data goes over to the corporate side. And we do have a data mart platform that is a good repository for both operational and non-operational data on the corporate side. And this is the end result on the right here. In cyan or light blue is all the different data types from all the different sources, and in green is all the different business groups in the utility. It could be up to 25 to 30 groups in the projects I've done that all now have the data they need to populate the applications, and they can provide the most value now to their organization. Okay? So when we talk about standards, one of the things we had to do early on when we talk about grid modernization is at GE we say SmartGrid goes from turbine to toaster. Okay, so it's a wide landscape from generation to your home. How do you draw that? You know, what does that encompass? And on the left here is a SmartGrid conceptual reference model that was done in 2010 with 7 domains and the interconnection of those 7 domains. This was a very, in the beginning here, to get our arms around what are we talking about with respect to looking at a utility and looking at the major domains and how they're interconnected together. But then in 2007, ESA, Energy Independence Security Act, made NIST the overall coordinator for smart grid standards in 2007. In 2009, they received stimulus funds to begin that work. They formed the Smart Grid Interoperability Panel, which I was elected to and chaired the board of, and some members of the original SGIP are here in the audience also. And we're responsible for coordinating all the smart grid standards work for the United States and harmonizing that with other countries. And so one of the challenges to make things simple for industry was IEEE, one standards development organization, had over 100 existing standards that touched on different parts of SmartGrid. The IEC, which is another standards development organization in Switzerland, had identified over 100 of their standards. So collectively, we went through all those and said, how can we make this easier for our industry? And we looked through these and we said, these are the 16 foundational standards for grid modernization. That any project you do, any product you develop, any research work you do at a university, forget about the hundreds, just focus on these 16, whether it's generation, transmission, distribution, or the end-use customer. But if you don't, you better have at least one or several of these involved in what you're doing, or it won't work. You won't be able to interoperate, and you won't be able to integrate, technology components. These are key to success, and these are foundational. Okay, I'll give you an example, a couple examples here. I've been leading standards work for over 30 years in the industry. This top, when one control center of a utility wants to talk to another control center, we used to have 3 different ways to do this in the U.S., many different ways around the world. There's one worldwide standard now, one worldwide standard. So if any utility is buying a new SCADA system, new EMS for generation transmission, DMS for distribution, you'll have at least one of these called ICCP, Intercontrol Center Communications Protocol ports. So we've converged. It's much easier now. Between control center and field equipment, there's primarily 2 standards worldwide that we use. One for North American suppliers and one for European suppliers. And within the field equipment, primarily 2 around the world, okay? So it's much easier now. So what we're talking about, if we were talking about this 10, 15 years ago, it'd be much more challenging for electric utilities and for vendors. Now it's much easier. We've converged over time on a very, very small number, okay? So that's a brief overview, and I want to, hopefully there's some time for some questions. Thank you.
Thanks, John. We got off to a slightly late start, so we'll open this up for maybe 6-7 minutes of questions.
Okay.
I'm going to go ahead and start with staff, actually. Christina, do you have a question that you'd like to ask of John to begin with? Okay. Marianne?
Thank you. When you're looking at these standards, now that we have underway in this nation, really the IP transition or the Internet Protocol transition, and we're looking at that very closely here in Ohio, the fact that we have telephone companies that at some point will be abandoning their copper that's in ground and replacing it with something else. Does the group that you're involved with, is it looking at any of this IP transition and how it is going to impact the utilities?
Very, very much. In fact, just on this slide itself, the control center to field equipment, for instance, the DNP3 or the IEEE 1815 was originally developed for serial networks because that's primarily all we had. But now it can that same protocol can operate over serial or network communications. Okay. Call it DNP3 over TCP/IP. So the same thing is true with the next one with European suppliers. If you notice, 101 was serial communications only, and that's what originally existed when we did the standards in the 1990s. But as more network communications was available and being used by electric utilities, we developed, 104 was developed, which is that same protocol over network communications. So we've, the key, the most important communication protocols now can be used either over serial or network communications. Yep.
Thank you.
Thank you. Beth?
No, thank you right now.
Dan?
John, thank you very much. At the outset, you said that we need to have a strong grid before we have a smart grid. And you also, I think, said that in order to have a strong grid, you have to have good standards for communications, integration, interoperation. I may not quite get it right, but you have to have good standards. And the question I have, and then you've you've kind of surveyed some of the work that's been done and the net result of the work that was done to come up with standards. At this point, do you think we have a robust enough set of standards to cover the different things that we need to cover in order to establish a strong grid? At this point, is it a critical path item that needs to be traversed, or do we have something in place that we can rely upon that's good enough from your judgment?
That's an excellent question, because if you waited until in your mind all the standards were finished, you'd never implement anything, because it's a journey, not a destination, right? We learn as we go. The answer is definitely. As was said this morning, there's certain parts of the grid or parts of technology that are new, that maybe standards are being developed. But in general, we've come a long way in 20, 30 years. And the critical things that we need to do, we have not only standards, but we've converged on either one or a small number of standards. So it's not only having the standards, but if you had a choice of 10 different ways to do it, interoperability would be very difficult. If you have one, interoperability is much easier, right, across vendors. So I would say there's some areas where we're still developing, like the customer part of SmartGrid. We have less experience with in-home enabling technology and automation on the customer side. Those are still developing, but we have a new final standard now with communications from the customer up to the grid and vice versa, called IEEE 2030.5, which is new, final, and it's being implemented now. The 3 California IOUs are implementing that in a big way with their future platforms, because that is the future. So that's new, but it was market based, right? There's a lot of movement on the customer side of SmartGrid. And so that accelerated this work, finalized the work, and now it's being implemented. So what we do is we definitely have a very, very good group, and we've converged to a small number. And we've also identified those areas where we need standards or changes to existing standards, and work is going on there. Yep.
Thank you.
Larry?
Just very quickly, John, first of all, thank you. Your group, there are traditional stakeholders involved in the discussions, I'm quite sure. Are there non-traditional stakeholders being invited into the discussions about standardization? And if so, are they receptive to the notion of standardization?
That's a really good question. When the SmartGrid Interoperability was put together in 2009 to cover all the stakeholder groups, and a lot of these were new stakeholder groups in SmartGrid, and have that reflected on this new board, there were 22 different stakeholder groups identified. The board we had was 25 people, one from each of 22 groups, plus 3 at large. So yeah, it's a large group of stakeholders, many non-traditional, and they've all embraced the fact that for any of these stakeholders to be successful, you can develop technology yourself, and it may work on its own, but the real value is when it's integrated in with something bigger, right? We say that the sum of the component, or the component itself, has value, but it's the integrated solution that has the most value to the electric utility. So you've got to embrace standards, and you've got to be able to take what you have and be able to integrate it and have it interoperate with others. So it's a large group, a lot of non-traditional, but everyone's embraced it, and they see the need for it. Yep.
Very good. Tom? Okay. So, John, thank you very much. I think we're going to have an opportunity to further dialogue with you through these panels. So thank you very much. Let's go ahead and call our next panel up. It's our Communications Requirements panel. So Mark Burke, Vice President, Energy and Utilities from Ericsson, Greg Myers, Vice President, Global Marketing, Sensus, a Xylem brand, and Jim Boch, Chief Engineer, Energy and SmartGrid, IPKeys Technologies, LLC. Gentlemen, thank you very much for joining us. Mr. Burke, would you like to lead off?
Sure. So, thank you very much. Maybe a little background on who Ericsson is. we're the largest manufacturer of wireless systems in the world. Our scope of activities include network infrastructure, managed services to operate that infrastructure, and software and services to deliver communications and media products. We're a R&D driven firm. We spend about $5 billion a year in R&D when you have several sites here in North America. We work for a number of utilities, mainly in communications infrastructure and management of that infrastructure. So following up on what Mark had said, indicated the implementation of SmartGrid places considerable challenges on the traditional way of working for electric utilities, particularly in communications. What used to be a sort of a radial system, generation, transmission to distribution, has now become more of a networked infrastructure where all end devices are now communicating upstream and interacting locally with each other. That might be viewed as a futuristic kind of a viewpoint, but it's happening now. There are customer end products that help them manage their own energy usage. There's a large-scale electric vehicle charging infrastructure being built out. There's a number of distributed energy resources and renewable integration programs going along, and also there's microgrids being built. This is being done sometimes in coordination with the electric utility and sometimes independently. So what this drives is sort of requirements for utility communications that focus heavily on reliability and resilience. John mentioned it, so did Mark, but basically what that means is uptime and outage recovery. So you have redundant paths and you use multiple technologies to limit the impact of any outage, either a weather-caused event or another cause. You can sustain impacts and recover within minutes. Also, safety and security. Field forces are dispersed in the service territory, knowing where your people are, what their state is. If there's a problem, that you can get emergency service to them at all times. Also, managing your operational expense, making sure you get the right resource at the right place at the right time with the right tools. And then finally, there's also regulatory requirements, namely the NERC CIP, having to do with protection of the bulk power system, which requires lots of cybersecurity concerns, access to data, control and tracking of who has access to the data. And finally, trying to leverage the new technologies like AMI, distributed energy resources, electric vehicles, and renewable integration. So in summary, the utility requirements can be broken down into mission critical functions and non-mission critical functions. But really that has to do, in communication speak, is capacity, latency, asymmetry, and it varies on the use case. AMI, for instance, doesn't require very low latency. Teleprotection, however, requires extremely low latency, and what's unique to the utility industry is latency asymmetry. So in other words, a reverse path is limited to, and this is measured in milliseconds. SCADA is also latency dependent, but that's usually unidirectional. Goose messaging, which is John mentioned 61850, that's used for substation communications, is a very latency intolerant protocol. Distributed energy resources, latency is very important, but not nearly as demanding as teleprotection. And then LAN data, local area network data, mainly has to be highly secure. The latency requirement is not as demanding as teleprotection or SCADA. And then there's mission critical voice. In other words, you have to make sure that you're able to talk, when you push that button and talk to your dispatch personnel, that you have no contest and you have priority and preemption. So combining all these requirements is really the challenge for a utility in planning and deploying and renovating their communications infrastructure. Putting that into numbers, typically what we call in telecommunications availability numbers, we're talking about a number of nines, like 4 nines, 5 nines. In a sense, what that means is the outage requirement for a telecommunications infrastructure is more demanding because it's supporting the electric delivery system. So in other words, we don't want to have a situation where the service requirements of electric delivery are hampered by the quality of communications. So subsequently, we want to have very highly reliable communication systems with high availability. The challenge that has when trying to deploy that when we come to owned versus leased or outsourced is, are the carriers able of providing that level of service, and does it make economic sense for them? And in many cases, it does not. So that's really a challenge. So the solutions and considerations almost all utilities have to grapple with is standards-based solutions. What's great about standards-based solutions is they offer built-in interoperability, huge economies of scales, no dependency on a single vendor for vendor viability or technology resources. Often in the past, there's been situations where a utility has bought some very interesting and innovative technology only from a single vendor. Only, unfortunately, the vendor doesn't sustain in the market very long, and they have to buy the intellectual property at a bankruptcy court, hire a lab to try to continue it, and it just becomes the total cost of ownership of that system is unpredictable. However, proprietary solutions can often bring interesting innovations to the market quickly, whereas if you go through the standards practice, it takes a long time to ensure that you're compliant and you're tested and prove it. But what we've seen in practical terms is a hybrid, that the proprietary systems that are out in the field have to be accommodated, have to be maintained, and as you migrate gracefully to a more standards-based architecture, you do it over time so you can make sure that you have minimal lost investment. So this gives you an idea of sort of a notion of how the network evolution of utilities are. What we're showing here basically is we have a core network that's supported by what's called IP-MPLS or multi-protocol label switching, and then it goes to an aggregation rings that can be provided by fiber or microwave, and then reach out to the substations and beyond to the line devices and perhaps customer devices and meters through a field area network, which could be LTE, WiMAX, or other technologies. One technology I like to point out is what's called long-term evolution, LTE. This is the basis of your smartphone, and why it was developed by what they call the third generation partnership program. It's a global program that communication vendors, users, telecom operators, and utilities participate in. They held 4 times a year, they hold sessions. The idea is to accommodate and to address those issues associated with forward and backward compatibility, so that an investment today doesn't go out of date in 10 years. Even though applications may migrate, that is generated into a standards format so you can accommodate new applications without having to renew your entire infrastructure. The foundations is it's a simple network architecture. It's internet protocol based. It offers high levels of quality service and policy control and priority handling. So in other words, you can maintain down to actually the bit level certain priorities. So we can say that teleprotection is priority number 1, mission critical voice is priority number 2 for access to the network. So we can specifically design a network for and deploy it for the priorities of a particular user. There's also a secure ecosystem, a high degree of security overlaid in this standard. And also the standard offers, right now LTE will close over 5 billion connected devices this year. So it offers the highest level of economies of scale. Last year, a wholesale LTE module cost about $45. A 5G module that'll be delivered later this year is $5. So, and the only reason you can get those economies of scale and reduction of cost is by having billions and billions manufactured over a global standard. The wide range, what LTE offers is a wide range of uses, both from massive Internet of Things deployments or very dense deployments where you have large bandwidth requirements. So you can reach small devices, Sensus devices, with very long reach with narrow band, or at the same time you can offer multi-megabits in a substation or at a service center or an office facility. The connectivity options, the challenge we have there is in North America is that spectrum this is a wireless solution, so spectrum really is the beachfront property of this solution. And so you can either use service providers, so the mobile network operators, and where you can they can offer you a service, or you can build a private network. Mark talked about two concepts called mobile virtual network operations or private virtual network operations. Those are both options can be available, and they're both being done in North America. And you can leverage licensed or unlicensed spectrum. You can do a portion. You can do a license, say, of 5 megahertz, and then back additional bandwidth for unlicensed when you can partition between mission-critical solutions and non-mission-critical solutions. So what the offering of the LTE networks is addresses the diversity of your requirements, both of the low latency and narrow band, but also high security and high bandwidth in a single architecture. So the promise of this standards-based solution is that you can accommodate all field communications in one network. But you can discriminate that one network within use cases for security performance, access, priority, and delivery. Utilities adopting LTE currently, Green Mountain Power, Southern Company, and OSGrid. Southern Company serves Georgia Power, Alabama Power, Mississippi Power, and Gulf States Power, so essentially the Southeast. Okay. It gives you an example of Southern Company's program. Essentially, they were replacing a obsolete land mobile radio system called IDIN that was out of vendor support by Motorola, and they were rolling out a quote-unquote a future-proof technology throughout their service territory. And they're serving mission-critical push-to-talk, distributed automation, distributed energy resources, metering, and smart lighting. Ownership structures of such networks can be fully owned, hybrid owned, or primary leased. Those decisions usually are based on what's the least cost of the ratepayer. And sometimes when you do it over a 25-year period, you come up with surprising results. You might think that leasing might be the cheapest way to go because we avoid that CapEx. But over time, that lease cost can build up. Here's an example of mission-critical push-to-talk. This is compared to a P25 traditional land mobile radio handset. This costs $400 if you buy one unit. If you buy 1,000 units, it's $200. Compare that to a modern P25 solution, it'd be about $1,300 a piece, no matter how many you buy. Another example is combination of electric vehicle storage with telecom and microgrid. This is a challenge. Largest electric vehicle manufacturer in the United States is rolling out, they want to roll out 5,000 electric vehicle charging, but those are very expensive. They have difficulty with site acquisition. At the same time, the wireless carriers, mobile network carriers, need to build out several hundred mobile network base stations. They also are for their 5G ambitions. And so what we've come up with is a solution where we build a combination where we can accommodate multiple mobile network operators, so they generate a lease. The supercharger can be accommodated, and we provide advanced storage. So this is essentially a distributed microgrid that is being deployed. And there's some pretty pictures of what the poles look like. They come in amazing colors. Cities like them because they're a lot prettier than the traditional mobile base stations. The future of this solution will be what's called network slicing, which will be able to support multiple industries, both utilities, the electric vehicle manufacturers, the landlords of the buildings, the Thruway, New York Thruway is very interested in this, and essentially it's a common infrastructure that the pieces of the network can be sliced for their requirements. So, any questions?
Thank you very much, Mr. Burke. We'll actually field questions when all three panelists are done. Thank you very much. Mr. Myers.
Yes. Is it? Yep, there we go. Thank you for this opportunity today. We're looking very forward to this. We've put together a presentation that takes advantage of the experience that we have in deploying smart utility networks, both electric, gas, and water throughout the world. We have about 35 million connected devices today. Been doing this for about 25 years in the industry, and want to share some of our experiences in the industry. We've formatted this into key questions that you should be asking as you go through this evaluation process. Broken into 3 categories: network infrastructure, interoperability, and integration, which we've heard a lot about interoperability and integration today. So expandability under network infrastructure, can the network expand over time? That's one thing that we have found to be critical to the longevity of a system. One thing's for certain, the evolution of the energy industry is going to continue. Requirements are going to change. As you can see from the diagram, the data requirements are going to change as the industry has moved from AMR to AMI to SmartGrid to now grid modernization. The requirements on the network, the data requirements, the application requirements are going to change, and you need to be able to have an infrastructure that can evolve with that change. It's one of the reasons that Sensus has chosen to operate on FCC licensed spectrum. It enables us that capability to change and add capability and capacity as we move forward. Extensibility, there's been a lot of discussion about can a network meet the changing standards. There's been a lot of discussion about what those changing standards are. For years, we lived with a couple standards, ANSI from the metering perspective. Then eventually, as one of the speakers made comment on before, DNP3 came along and it homogenized all of the distribution automation devices into one common standard, which made it much easier to be interoperable with. More standards are coming. They're right now, as distributed energy resources are becoming more and more prevalent. There are standards like we'll hear about OpenADR, SGIP, Zigbee was one that was introduced as part of the AMI standards, but those are going to continue to evolve and become part of the network web that you're going to have to be able to support. So as important as the standards are, a communication network that can, regardless of what the standard is, provide that interoperability from the endpoint to the application is the most important thing. Compatibility. So the network must keep pace with an evolving grid. Is the network backwards compatible? Is it future ready? So those are 2 dynamics that are difficult to balance. You want to 90% of the investment that you'll make when you put in a smart grid or grid modernization system is in the hardware endpoints. And you want to be able to maintain those while being able to, in the field for their lifetime, while you continue to add new applications to the system and be able to manage those as well. And I've got a chart there showing, really the baseline for AMI was meter reading automation, remote disconnects, outage and restoration, and home energy management, and it kept evolving, right? Home energy management was added on. Now we're getting into a lot of analytics. More and more data is required from the analytics side of things, and now distributed energy resources. And the ability for the system to be able to provide the different communications to those devices, as well as grid edge communications. Resiliency. Again, another reason that we've chosen to be on licensed spectrum is because it enables infrastructure for the utilities to be in hardened locations like substations and communication towers. This is a diagram. Can the communication system aid in power restoration? This is actually a picture of a Google Earth map of what had happened in Tuscaloosa back in 2011. Those red dots actually are outage last gas messages that were received from the system as the tornado went through. You're only capable of doing that if the system is in hardened locations that's not affected by the weather that's occurring, or depending on communications like cellular that requires that it ends up having a lot of calls and so forth when these activities are occurring. I'll get into interoperability and talk a little bit about that. Where does interoperability add the most value? Well, interoperable communications is one way to get devices, to be able to purchase devices from multiple vendors, but it doesn't do much in the way of making applications and devices be interoperable with each other. That's where the application standards come into play, and the ability to be able to connect those devices over time. A good example is, you have your iPhone or your smartphone, and you're in one location, you'll be on LTE, you'll be in another location, you're on 3G. Regardless of what the communication protocol is that you're talking over, your application and device are still operating. Maybe not as fast as you would like anymore if it's not on the LTE network, but those are the same kind of principles. By taking this type of approach where you can change the communications protocol to adapt to the evolving requirements of the industry, that enables you to keep pace with these applications while continuing to support the older applications. Opportunity cost. What compromises are made to be locked into communications protocols? So one example that I've just returned from an 8-day trip around the world, visiting multiple countries, talking to regulators, talking to utilities around the world. And one thing that is starting to be mandated now is that their systems have to be operated over licensed spectrum. Why is that? It's because of the hacking that can occur on unlicensed spectrum that anybody can make use of. And there's a lot of concern over that infrastructure being compromised because of those things. So they're looking very much to drive things into more of a closed environment. System support, what applications, devices, protocols are supported. The network has proven additional applications can be supported, and what are the plans for the future. You need to be able to ensure the desired protocols and applications that you're looking for in the future are going to be supported. There are things with distributed energy resources that decisions that need to be still made as far as how much data and how much do you do on the grid edge versus how much do you do from a centralized architecture where you're making decisions, taking a lot more data into account. So those are kind of the things that you've got to be adaptable for, or make sure that the system allows you the flexibility to take either approach and be able to support it. Proven ability, has the solution been tested and the level of end-to-end performance? What we've seen in the industry is that systems are developed initially to support metering data. A metering data system is not the same thing as supporting distribution automation. The data in a metering data collection system, you want all the data you can get so that you make sure that you have the billing data that you need or the voltage data you need to run your operations. In the case of DA, it's all about safety and making sure that the message that you get is the latest information and not all, if a message is old, you don't want the old message because it could end up creating an issue if someone's out visiting something and doing something on the distribution line and putting themselves in harm's way if the message says the power is out and it actually has come back on. So the system has to be able to adapt. That's one example of how you have to be able to do that. And one way of doing that is to actually segment that data in your network where the AMI data, the metering data, is handled separately than the distribution automation data, so that you can prioritize that data as it's going through the system, and the data isn't mixed in the way that you're collecting or the way that you're doing command and control down to those two different activities. In determining success, what type of integration is needed to realize utility goals. You want to be able to connect to new and old. I talked about some examples of that where you want to be able to maintain the devices for the life. There are some other examples where application level protocols have enabled that transition to happen and enabled utilities to maintain those assets. There are customers that we have that have POTS line and DNP3, POTS lines and 2G devices that all they have to do is unplug those devices and plug a different communications module in, and they can maintain those assets on the system. And then future opportunities, how can utility leverage integration? Utilities today are taking these systems and adding things like lighting control solutions to them to better support the end customers, as well as being able to also service reading water utilities data and so forth. So there's an extensibility as far as the network concerns and whatever that the utility and commission has in mind as far as what else do you want to be able to do with that network. And for wrap-up, flexibility is key to manage change. For certain things are continuing to change. I know in Ohio they are as far as population, consumer needs and choices, regulatory, technical landscape, generation and supply with the introduction of distributed energy resources, and then of course there's industry consolidation that it seems to be continuously happening. So, thank you.
Thank you very much. Mr. Boch.
Thank you. So how do I get to my presentation? There we go. Perfect. I don't build networks. I'm going to talk to you from an application point of view, and I'm going to talk specifically about devices that are not owned by the utility, commonly known as DERs. These could be typical building load. They can be EVs. They could be batteries, solar, wind. All of these devices that are suddenly very popular. We've done a lot of pilots with people who are implementing these things. I'll give you a lot of the lessons learned and give you a look forward so that as you encounter these things, you've been prepared. A quick thing, you probably never heard of IPKeys. I'm not GE or Ericsson. But we were on the SGIP panel at the same time John was doing that. We were selected by NIST to build the reference implementation for the standard that's commonly known as OpenADR 2.0. That standard was a combination of Lawrence Berkeley Labs and a lot of other groups, a lot of stakeholders to get a federally sponsored single standard for energy communication between consumers and suppliers. So it was designed to touch the edge. It's not 61850, it's not, talking to substations. This is talking to your thermostats, cars, things like that. And we built that implementation. It was successful, but the big question we ran into when we said, do you want to buy something, was, can an elephant designed by a committee really dance? And so we undertook a lot of pilots and did a lot of work to show the use of the standard in the field for the relevant applications that it was intended for. You all know this. There's a huge proliferation in all of these technologies. The military, we're a defense contractor also, and so all the militaries believe in being able to island. They all want to put in their own microgrids, but they all want to be connected to the grid and be sensitive to the price of energy, so they can do this energy balancing equation because, money is finite. The fuel cells, we're running in the city of Burbank. IKEA puts in a megawatt fuel cell, but still wants to be connected to the utility. So how do you get paid? So they give them an interconnection fee that's through the roof. They go crazy. So there's a lot of these complexities, but the answer to that was, all right, you're the first guy we shut off when something goes wrong. Is that okay? And, so you have interesting conversations. I can't attend a single meeting in California without seeing this curve. This is the duck curve. This is what happens when you shove too much solar on the grid and the sun goes down.
but everybody goes home and turns their air conditioning on. Suddenly you've got this huge rate of change where traditional generation has to come up. Maybe you can buy, several $billion in batteries and solve the problem, but in 10 years when you have to throw them away, what are you going to do? Is that a super fund issue? So how do you solve these problems? How do you talk to these devices? These are all the kind of things that you're running into. We see 3 networks out there. You've already heard this. I'm not going to get into much. AMI is the obvious choice. So when the ARRA money came out, everybody got their free smart meter and they deployed them. But that ARRA money didn't give you the network. And so I've been to many Marine Corps bases that have these beautiful, new Itron meters or something like that out there, and no network to connect it to. So what we have found is that the networks that were put into position to read these meters are pretty much restricted to meter reading. If you really want to get into real-time communications, you want to do the whole sensor actuator thing for 100,000 customers, those networks are going to have to be upgraded if you're going to use them.
Mr. Boch, I hate to bother you.
Too low?
Yeah, thank you very much. Appreciate
Better?
it. Yep.
Thank you.
I think you're taller than the average speaker. Thank you.
I expect. In 2013, we worked with the Dolan Lab, the AEP Dolan Lab, on their interoperability report. They said that they were doing the robustness of SEP testing. I do not have this report. I reached out to Sean Walton of AEP, the gentleman I worked for, and I said, would it be okay to share it with you all to read what your lab has done on studying the use of various protocols over various networks? So he's going to get permission. If they do, then I'll reach out to the panel and let you share that report so you can see it. I didn't write it. I didn't read it. They just told me what was in it. They said that OpenADR, which is the standard that we implement, did very well, 99% kind of behavior, so very good. Detroit Edison, when we were in the beginning, they were doing an electric vehicle pilot, obviously Detroit Edison, and we suggested the use of your AMI to talk to all these devices, and he said, God, no. And you have this wonderful AMI. Why wouldn't you use it to talk to all of these devices? He says, because I don't have the customer service staff to support all of the conversations every time somebody's device, their hand module or their price reader in their house doesn't work. If they call me, I can't support that. I want this to be on somebody else's network, and I want somebody else to have the customer service. That was a big surprise to me. That was Hawk, the gentleman Hawk here. And then the city of Burbank. We did their full deployment. It's a mesh radio system with fiber backhaul. And that is designed to, it's the second fastest mesh radio network for AMI in the world when we built it. And it was designed as a citywide project. It's designed for the people to be able to pull down plans for approval, video streaming from the police cars, things like that. Those kind of networks can do full communications for interoperating with DERs. So you run the scope. You run from the ones that are strung together at the Marine Corps to the ones that you can run full motion video over. So that's AMI. The internet, this is, everybody's using it. It's building up and it has nothing to do with you. And in most cases, you didn't pay for it. Your biggest issue is security. You're running over an open network. There are bad people out there who want to do bad things to your network, and they want to disturb you. So you have to very much protect yourself, and that's going to be a standard. But it's beyond the standard. It's not just the communication protocol. It's the hardening of the end devices. We're sponsored by the ESTCP. That's a government organization to do pilots and energy projects, water, things like that, to come up with a cyber-hardened endpoint that runs OpenADR that can be used in that. And so Camp Pendleton will be deploying that in a few months. It gets through the whole, I don't want to get into DITSCAP, DICAP, RFM, but the bottom line is it passes DoD standards. So you have to harden the devices as well. It's not okay enough to say, is it OpenADR? Has it been evaluated for security also? Because you don't want these cool thermostats to be used to breach your network. So the isolation. The last one is private networks, of course, and these gentlemen have done a great job on this. We've talked to Southern companies. They rolled out an LMR system to talk to their internal DER. They're rolling out a full LTE system. I found out it's Ericsson. I didn't know that at the time. To do that, they're a big believer in private network. So you can do DER type communications, and we're also working with Motorola, but I don't think I pay that much for a P25, so I have to check that price. But a private network is your other solution. Do you put in your own network? Now you're isolated from the world. People in Chechnya are much harder to hack your network, but it's quite expensive. So that's our point of view on the networks. Now let's talk about the standard. We're an application company that builds products that run on networks. OpenADR2B, that's commonly known, it's the standard, is actually Energy Interop. It's run by Oasis. It was a product of the SGIB process to do that. We received our work in 2010 to build it. It does a control by standard, do a DR event kind of thing, the way California uses it. It also is used for convey real-time, time of use kind of pricing, and real control. It has what wasn't available before is near real-time feedback. So you can pull meter readings in 5 minutes at 1 minute granularity. And there are very few AMIs in the world that can do that. So you're talking to a subset of your meters in your environment, but you can read them very quickly. And what we find is this gives you the ability to make decisions before it's too late. In the old days where they would do a DR event, they would say, I said, well, are you concerned about performance? He goes, listen, we look at our substation meters, we look at our state estimators, and we work it out in the bill. So whether you perform or you don't perform is irrelevant during the event. They hope you do, but they're not using it as a control factor. With the advent of the big data technologies and the near real-time telemetry, you can start using these field pieces of information from like your renewable resources to start making decisions. And we're seeing some of that convergence to the control room rather than, thank you, rather than just being in the billing modes. Data volume is relatively low. It's about 150 megabytes per month. It's got authentication by certificate, which is same thing as your bank kind of thing, but at both ends. It's fully encrypted. And we always suggest a separation from your utility SCADA. This is going to touch hundreds and thousands up to millions of people. Those are a lot of exposed points. Security model says limit your exposure. So you want your threat surfaces to be minimized. When we did for the city of Burbank with a Telvent system is we built a single channel VPN with one-way communications. So it's very much like a SCADA system with the separation of the story and the control platform. We always suggest that. Get your application that talks to your millions of consumers and keep it away from the inside of your control room. That way they can't use that as a gateway to hack you. And then I'm sure the security guys will tell you all about that. So I am not moving anymore. Did I break it? Pilots. So with the players on the screen, we demonstrated that you can do capacity signaling, you can do sync reserve signaling, and regulation signaling. This standard is fast enough to do regulation. So you can do all three. We were then working with LB&L and Hawaiian Electric, which has a huge solar penetration problem. Came to us and said, can you use this standard to help us regulate our solar problems? Way too much rooftop solar, rains every day. We need some balancing. So we did pilots with them to use pumping, like water and wastewater, to balance it. And so we just control the VFDs to match the solar. It worked and it was great. It scored at 94% accuracy in the PJM scale. And then right now we're doing the DOE with National Grid on a high penetration. So when you get above 60% solar penetration area, the tail starts wagging the dog. And you've got way too much energy in the spring and fall, not that. You can solve it with a battery, but it's a really big battery. And so the pilot is, can you use this standard and buildings to act as an ancillary battery? In other words, can the buildings adjust their behavior and to what level? And it's part of the Shines project, so we're doing that right now with them. So my recommendation is that you adopt standards, absolutely. When you deploy these solutions, if you just make the rule that says this needs to be OpenADR in order to receive funding, in order to receive your free device, to connect to our interject, to get value for your net metering, The utility is not tasked with working out all the details. They just say, you need to have this standard, and standards will drive it. So we suggest that you review the standards and recommend the adoption of OpenADR2 for the control of the client-side DER devices. That's it. Thank you.
Thank you very much. John, my understanding is after the panelists spoke, you wanted to do a little summary piece, and then we could ask questions of the entire unit.
What I'd like to do is pull together what we heard this morning, from Jeff and from Mark and the three speakers, and then kind of pull it together, and it's just some key takeaways, which I think will stimulate some additional Q&A. A couple points. With the communications infrastructure, one size doesn't fit all. The infrastructure it's a hybrid of many different technologies. But the one thing that's important is when we talk about different applications, which Mark emphasized, was each application has its own response requirements in seconds, its own bandwidth requirements in bits per second, and its own latency that it can tolerate in seconds. So when we look at all the applications that we want to include today and in the future, we have to make sure that underlying communications infrastructure, which is a hybrid of different technologies, can support these different metrics with each application. Okay, so we know what, we have the response requirements, we know what the bandwidth requirements, we know latency, but these are the things that we have to make sure can be supported, and in a sense have some idea what we might want to do in the future to make sure that underlying infrastructure can support it. Okay, I think it was Mark this morning that said, emphasize applications drive the requirements. So we look at what the applications require and make sure the underlying infrastructure can support it. The decision points are very critical that we've talked about this morning, and what Mark talked about, three major decision points with communications. As we look at the different technologies around the infrastructure, do we use wired or do we use wireless, right? We can use fiber, we can use microwave, so we have choices that would meet the requirements of that part of the infrastructure, wired versus wireless. Second would be private versus public. It used to be, some time ago, utilities would spend much more money to build out their own private network because they controlled it. And if there was a problem with critical data like SCADA, they were the ones that supported it. They didn't have to rely on a third party. And the third decision point is licensed versus unlicensed. If you're in an urban area where there could be more chance for interference, license makes sense. But when you're out at that last substation in a rural area, you can save money and use unlicensed, right? So the decision point of when do we use licensed and when we use unlicensed with wireless communications. And then lastly, with Mark, was critical versus non-critical data. It used to be the utilities would say, there's no way I'm going to let my critical data leave my premises, go out to the cloud, or go out, to a hosted system, right? And that's changing today because of the value we receive by using a cloud type platform. If we receive value from something, some of the concerns will go away, like privacy of information goes away with Amazon Prime. When you log on to Amazon and says, hey, these are the things you just bought recently, here's some new products that we think you would love to buy. Well, you could look at that as intrusion of privacy, but we look at that as value. And so we like that. So critical versus non-critical data. When we look at the data at a utility, typically classify what's critical, what's non-critical, and then the decision is, how do I feel about critical data like SCADA type, real-time information, leaving the premises and going to a hosted application in the cloud or somewhere else, okay? With Greg, a couple things. One was very important point, network backward compatibility. When we write standards, we got to make sure we not only look forward, but we look backwards, right? This new standard that you're going to implement, we can't, we have to make sure that all the existing equipment, the legacy equipment in the field, still will work, right? And so in a real utility situation today, we have three basic situations. One would be totally legacy. It's all old equipment. It's going to continue to operate the way it is. On the other extreme would be totally greenfield. We're building something brand new. Okay, then we can use new equipment, new standards. It's pretty much wide open. But where we spend most of our time is in the middle. It's a hybrid situation of legacy equipment working together with new equipment. And that's a challenge. Okay, we want to make sure with these new standards and the new equipment that we're still getting all the functionality that we need from the legacy, from the old equipment. So backward compatibility is really important. Compliance, though, to a standard with a vendor's product does not guarantee interoperability, okay? You could get certificates from vendors that they've independently tested their products with a certain communications protocol. All that means is it was implemented per the standard, but when you connect different vendors' equipment together in the field, it may not talk to each other. Okay, Beth talked about how do we future-proof? We call it investment protection. There you want to not only look at compliance, but you want to look at interoperability testing. And the user groups of the key standards have what they call plug fests, where vendors bring their equipment, connect it together, try to talk to each other over several days. They have software developers there. When incompatibilities are detected, you change the code on the fly, and at the end of a plug fest, all the vendors there and all the equipment, the models of equipment they have, truly interoperates. So to future-proof, you got to know what questions to ask, which vendors have independently tested their products, but also which ones have participated in these industry get-togethers. Okay, and the third thing with Greg was one of the lessons we learned with deploying SmartGrid projects was testing. You can't do enough testing in the factory, before you get to the field. It's very difficult to test something in the field. It's much easier, and that's why so many utilities have developed labs, very sophisticated labs, to do testing before you get out in the field. But the one thing we learned with metering was end-to-end testing is needed. Not just testing the meter and the communications there, because we did that, then we brought the meter out to the field, and it wouldn't communicate to the head-end system. See, end-to-end testing. These solutions go from, a device in a substation up to the control center or the office, and you got to test all the ends. And then lastly, with Jim, it's very important that I talked about holistic. Jim gave a good example of a utility, the metering group in a utility wants to get into smart metering, so they write a procurement spec for smart meters and AMI communications, but it only requires the functions of the smart meters. God forbid you put in this huge AMI communications infrastructure. A year later, they want to do distribution automation, feeder automation. And they assume that communications infrastructure for metering will support distribution automation, and typically it doesn't, okay? So what you have to do is, the bottom line is, if any group in a utility wants to buy new technology, don't just think of your own needs, think of the possible needs throughout the whole utility, all the groups, right? In this case, before I do an RFP on AMI communications, I think of the distribution group. I've got a communications infrastructure across the whole enterprise, right? It can meet a lot of different groups' requirements. Let's put all those requirements in the original RFP, go out for bid, and then we have a stronger business case because the technology we buy can meet more needs than just one group. It can meet the needs of more of the utility. Okay, so think holistically. With every investment should be looking company-wide, organization-wide with respect to requirements.
John, thank you.
Summary.
Thank you very much. Look, so I didn't ask questions of the previous few panels, so I'm going to take some liberty here and try and, from an economic regulator standpoint, hone in on, John, as you described, decision points. And so let me just sort of, I'm going to think out loud, and everyone can opine as we're thinking out loud here. So, from phase one and this morning, I think it's pretty readily agreed upon that there needs to be this communications network and overlay on top of physical grid infrastructure, and that's going back to Jeff Taft's slide, core elements. I think we can all derive some consensus there. Correct? Okay. So then from there, we start talking about, or what we've been talking about the past few panels, are the different types of potential, networks. And so, Mr. Boch, you brought up AMI, internet, private. I think we've had some robust discussion about private networks as well. So, on that piece right there, I'm going to ask this question probably. I don't know if I should ask this question. Who makes the decision about that? So is that from the perspective of the panel, or even I see Jeff in the back and I see Mark in the back too? Is it the regulator that makes the decision about the type of network, or is it the utility that makes the decision, or the whomever is the I don't want to put the cart before the horse. Is it the platform provider that makes that decision based upon what's happening in the footprint or the state? Anyone have any thoughts about that, Mark?
I think making reference to Mark's earlier comment from EPRI saying the application, the use cases drive the infrastructure. And so if you want to have, what we've talked a lot today has been sort of classic infrastructure economics. In other words, do the most with the least amount of investments, but as much use cases in the common infrastructure, and we have least amount of stranded costs. The decision of whether to go private or public or hybrid is sometimes depends on where you are and what private options you have and what public options you have. I'll give you an example. In Holland, a utility is quite common to use the public network for their backhaul and field access communication systems. And that's because their public network carrier signs up to a service level agreement with penalties associated with the performance in the electric utility system. So if there's an outage, they're subject to penalties, financial penalties. In this service territory, I don't believe too many carriers will offer the service level agreement with associated penalties that the utility is facing. So that you have to look at what is available. So if an application requires very high availability and reliability, right? What is it technologically needed to serve that, okay? And then where is the ownership structure? And I've proposed that it should look at the least cost to the ratepayer, because that's who's paying for everything, right? So the idea would be is to compare, can we get a public solution that'll give us adequate performance for the applications that we wish to do? And so that is not an easy question, because it's a moving target. What carriers are willing to do and not willing to do. By the end of 2019, in most of this state, you will not have 2G, and you will not have DS0s, traditional POTS lines anymore, because it's non-economic for the carrier to provide anymore. So not only is it technologically appropriate, but what is the lifespan of that solution? And typically, most utilities take a 25-year view, and they want to have a technology refresh in there. But if you get into a public carrier partnership, well, what is the public carrier willing to do? And that has to be balanced. So I'm afraid I don't think it's an easy answer. I hate to give you a question back, but really you have to see is what does this solution require, and then what is available over the period of time that we need it to operate. So, and who makes that decision? In most places, the regulators have left it up to the utility, and the regulator monitors the utility for performance, not for particular technology selection. Right?
So with respect to, so thank you for that answer. Does that answer also apply? I'm looking specifically, you don't have it in front of you, and I'm not going to ask you to pull it up. Mark McGranahan's slide 10 that has spectrum type, ownership, network core. So the concept of licensed or unlicensed spectrum, or leased or utility-owned spectrum.
Sure.
These are factoids, or these are pieces that also
That's in the puzzle.
That's all part of the puzzle as to whether or not,
Right.
as what type of network.
Right. I'll give
okay.
you an example. So Southern Company has licensed spectrum that they acquired, and they're putting an LTE system in a license that they have exclusive use of that spectrum, and they're doing full DA, metering, everything in that thing. Now, another utility that is adjacent to them does not have adequate licensed spectrum, but they are leasing spectrum from a mobile carrier. They're leasing 5 megahertz. Now, they're not paying for it with cash. They're trading. They're giving pole attachments and access to their infrastructure to the mobile network operator. So essentially, they are acquiring the spectrum through other means other than payment. It's sort of a barter type arrangement. So that gets to the point of license. Now, unlicensed, it offers other solutions. Like John said, it might make sense where you're not worried about hacking or interference, co-channel and adjacent channel interference. So all those elements that you list are part of the decision tree, I would say.
I think probably what makes sense here is for us to develop probably a preference. And then if there's deviation from, again, I'm just speaking out loud. This is probably a conversation I shouldn't have out loud, but whatever. And if there's deviation from because what I'm trying to get at here is, how do you distinguish between the externalities that create the network and preference, which may not yield least cost? So what is actually possible within a given utility's footprint for the communication network, and which would result in least cost, versus what their preference is? I mean, those could be two different things, potentially, in tandem with what the commission's preference is. You see where I'm going with that? Which is, there are all of these potential pieces of the puzzle, and there's all of these different, there's the possibility of public-private hybrid.
Right.
Seems to me that we'd have to be thoughtful about what our desire is here at the commission for the creation of that network. Then we'd have to pair that with what's possible in the footprint, and that's another issue, which is we're dealing with 4 different footprints here. And so I would think that if you are an application vendor in the state, you'd love for uniformity, but that may or may not be possible, right?
Well, it's possible. I mean, you apply standards, and that's how uniformity is accommodated in interoperability. So you instead of getting if you focus on what functionally you desire at the least cost or the optimum cost to the ratepayer, because maybe the least cost isn't the best choice, but optimum cost, best value for the and leveraging to the greatest extent possible global standards or industry standards. That should give industry enough accommodation to come up with an innovation, both public and private.
Yeah, I hear you. I think an issue that we do run into with some frequency around here is that which we desire is sometimes in one territory acceptable, in another territory extraordinarily high cost because of fill in the blank. And so that's a challenge. I've got some more, but does someone want to continue on with this question lineage? Let's go Christina, Larry, Dan.
So we've talked a bit about just how the EDU technology investments and the lifespan of those investments may not match from a lease option the contract lengths that are available from, communication providers.
Right.
Has that changed as, the demand has increased? And is it, from looking a prudency perspective, can you actually reasonably estimate or forecast the costs associated with these long-term, lives of these technologies with the changing communication needs?
Those are good questions. There's lots of questions. So the the accommodation of long-term leases for spectrum are changing. A few years ago, there wasn't any. You either bought it on the market from the FCC or you didn't have it. There are new owners now, Dish, and there's lots of spectrum out there that's not being used. The FCC requires that it be used. So there is an interest in leasing, either through cash or trade. So, and those terms of those leases can be lengthy, not 30 years yet. The estimated costs of total cost of ownership over a long period of time can be estimated within reasonable margins. There are a number of consulting firms that make their living doing that. So those two things have changed. Also, the cost of infrastructure, because we're going to more standards-based, I think everyone, today's panel has talked about standards, ultimately reduces the cost of infrastructure compared to proprietary refresh every few years.
Larry?
Yeah, the communication infrastructure design or options, are they hampered in any way by the age of the physical assets?
Sure. I mean, if something is beyond its useful life, you can't bring it back to life. One of the challenges you have is, I'll give you an example. There's a nearby state has an old land mobile radio system that's 15 years outside of vendor support. The vendor doesn't make parts for it. They buy it on eBay and used but good, things like that. So there is no future in that technology or that device. So the age of the or not so much the age, but how far they are in the product life cycle and roadmap of that product.
I think that's why the backwards compatibility piece is very important, because you can have aged devices working alongside next generation devices on a network if it's architected correctly, so that the collectors themselves manage being able to communicate to both of those devices simultaneously without any impact to the performance that you were getting before on the older devices and whatever applications that those older devices were providing.
And are there cost implications to integrate with an older technology as opposed to a new technology?
Yeah, usually there's an API has to be written and things like that. Yeah.
Dan?
Mark, I think that you shifted a little bit in the way you described the goal from, or maybe someone else did, from least cost to best value, as far as what we shoot for in setting the standard for what we're going to get from the communication system that's deployed. And it seemed to me, and correct me or comment on it, or any of you comment on it, that as the options kind of collapse from that are available, the public options compared to the private options, the ability to lease and operate on privately versus build and own privately, as the options collapse down, the ability to set a standard that's more of a least cost standard when you look at what you're trying to guide the communication system owner towards. It also tends to shift it towards the best value result rather than a least cost result. We're not really going to be in a position to allow, say, a competition drive us to the least cost result, because we can't afford to have a destructive competition in this area, it seems to me. So then we're left with a goal of best value, or maybe even reasonable or good value to shoot for as far as what we're trying to accomplish with the communication system. So that's my thought at listening to the conversation. Do you agree, disagree?
Well,
or
I've
is there
been in-
something I'm missing, you think?
Well, I make reference to those two different terms of art because I've been involved in programs that had different use. So in other words, most of the programs I've been associated with utilities, they go for a least cost of ownership to the ratepayer for the 25 to 30 year period. However, I've been involved with programs that were best value, and that was a term of art that was adopted because they were concerned about the lowest cost may not be the most appropriate over a long period of time. So it involved performance risk assumption by the framers of the process.
I think another critical variable in there is that you're right in that the service territories for the utilities in the state of Ohio, they vary between themselves, but they also vary from the customers that they serve independently themselves. They'll have dense environments and they'll have very rural environments. And one of the keys is being able to provide the same level of application support for all of those, for all of those scenarios, so no one's left behind as part of your selection process.
And that is a challenge. I mean, I've been involved with programs overseas, and the demand among the urban youth were very high. They wanted everything on their cell phone. They saw no reason to even having a meter on their building. Why can't their cell phone be their meter? And they want that cell phone to be their portal to all their vendors and everything. That's their life. That's the center of their life. Whereas, people of a different generation just want lowest cost. They want no functionality. They don't care how other people are using green energy. They just want reliable and low-cost electricity. Whereas the urban young want to see how they compare their energy consumption is to their colleagues and other people nationwide. In the UK, it's a big deal. You can pop up and see how you're doing compared to your neighbors and your neighborhood compared to other parts of the UK, and it drove customer behavior. I'm not certain if that would be uniformly the same way in different demographic groups in the state of Ohio. Maybe so in the urban areas, but maybe less so in rural.
Other questions? Tom.
Mr. Chairman, in certain ways, you've given us kind of a smorgasbord of different things in the communications area. And it crosses my mind, but that perhaps the best course is not to do anything or do much of anything in communications, although it's all coming. React to that. As far as Ohio is concerned, as far as other states are concerned, is there something that you think that, they need to be moving on, the utilities or the other groups need to be moving in certain areas? Do you have anything in mind that you might tell me, like the first steps? Or are we? It seems to me we're moving anyway. But just what is your reaction to that?
Well, if you look at from the consumer piece of it, there are a lot of, from just an AMI perspective, the utilities get a lot of benefit, and that's widely known as far as, now you're not driving to each house and walking to each house to read the meters and so forth. But the consumer's getting a major benefit from it in that, one, they now have more privacy. Their bills are more accurate. There's less things that they have to do to if their bill isn't accurate, they can call and they can read their meter right at that time frame. Same thing with prepayment. The prepayment is starting to take hold in a lot of places around the country, and not from the folks that you would think. It's not necessarily the folks that have trouble paying their bills, but it's folks that want to be on a consigned budget, just like prepayment phone cards and things like that. Millennials, kids in college, folks like that, they don't have to pay they don't have to pay the deposit and so forth. It makes things much easier so it opens up all of those things, as well as the outage and restoration piece, which is become invaluable to the utilities that have deployed systems, that they're able to actually restore power much, much sooner. They can find these nested outages where it seems like everybody's house is on but mine. Why is that? Kind of thing. They can determine why your particular house and send folks to those locations to be able to do that. So that's a few examples from that perspective. The other is that now the everything has evolved into SmartGrid and grid modernization, where when you are looking at adding distributed energy resources and solar, it does create a lot of havoc on the system. It can, the system is architected to deliver power one way. Now you've got intersections where other devices, other generation is being put onto the network, and you want to make sure that you can do the analytics behind when and where these things get added to the network to make sure that you continue providing a very valuable service to your consumers.
Yeah, I would add to that, the introduction of electric vehicle charging is coming on fast and furious, that are independent of a particular utility's interest or not. There's a major entrepreneur that's going to make sure there's 10,000 new DC to DC supercharging stations throughout the country. There are going to be several hundred here in Ohio. So that poses a challenge to distribution utilities. How do they accommodate that? How do they make sure they don't have too many on a feeder, reduce their planning costs? How do they know what the state of charge is to use it for their energy solutions? In addition, there's microgrids being built. Distributed solar is affecting in certain markets. The solar is problematic because of I think Mr. Boch mentioned in California. So I don't think the communication system that accommodates the utility sector will happen on its own the way you would desire without perhaps being part of the solution. That doesn't mean that you have to dictate what the solution has to be, but I do think an informed participation is prudent. Otherwise, there could be, we did a study with Baltimore Gas and Electric. Just so happened all the electric vehicles lived in the same neighborhoods, the same few feeders. They were popping transformers. That was really an unfortunate event, right? Why didn't they see that coming? Well, they didn't control the people who were buying electric vehicles. So, so that's these sort of changes that are happening faster, I think, than we first estimated a few years ago. So I think it'd be prudent, perhaps, to participate in the planning for these eventualities. Does that answer your question?
Let me just add one thing, Tom. Is the reason communications is so important is communications enables us to automate. In any automation system, you have a master, field equipment, and then the communications is a third part that glues it all together. If you don't do anything with communications, it limits you to how much you can actually do with new technology. In fact, it would limit you to take advantage of a lot of new technology. A lot of our substations today have serial communications, like we talked about. We don't have network communications. The bandwidth is a lot. It limits us to what we can do. There's a lot of new benefits available. We can configure a substation today in 1/10 of the time that we could not too long ago, but it's a new industry standard, requires network communications. Okay, so you could kind of sit tight, but communications is the enabler to do new things, and the problem is if you sit tight in general, you'll be shut out of doing a lot of new things, which means the benefits from the new technology you won't be able to take advantage of.
There's also a threat. I mean, there's 2G and POTS lines are being terminated in some parts of your service territory by December 31st, 2019. So some of those serial connections to the substations will not be active on the 1st of January, 2020.
Thank you. Beth?
John, I'm sorry, I have to ask this. This Plug Fest,
Yes.
how does one get invited to a Plug Fest? And are there T-shirts that you survived the Plug Fest? I mean,
An invite.
really? I just find this fascinating. So I've just been like,
You gotta be a nerd, though.
you got to be a nerd.
Be a
I can be a nerd for a
software
while.
programmer, Ponytail. I mean, you
Okay.
know, it's the guys who really write the code here. Right?
Okay.
Not pretty.
All right. That's all. I just wanted to throw that out. Thanks.
Yeah, I can talk to you more about that.
Okay, thank you very much. Wonderful panel. Really appreciate everything.